Hello 8th grade, this is Mr. Rogers and you're watching the video lecture for a brand new book, brand new unit here. We're on plate tectonics, and so lesson objectives here for plate tectonics 1-1, we're on the layers of the earth. And so our goals for the day, our objectives are to list the characteristics of the layers of the earth. So all the way down to the middle, what's going on underneath our feet. So today guys, on Earth's interior, what's going on in here? So it's kind of a note heavy day. We'll be looking at one picture here off and on. So first of all, I'll start with geologists. These are the guys we're going to become. We are going to become amateur geologists here over the next month and a half. And a geologist is a scientist who study the forces that make and shape Earth and search for clues about Earth's history. So trying to piece together the history of the Earth. And we're talking about geological time, we're talking about billions of years of Earth's history here. So over 4 billion years of Earth's history. So to do that, we study some different things here. We study what are known as constructive forces. And they shape Earth by building up mountains and land masses. So let's think about volcanoes would be a good as land. And destructive forces. These slowly wear away the features of the Earth. Let's think about erosion. Earthquakes can do that too. And you know, in previous times we've had Arnold, but I think I can do it myself here. I don't need Arnold to bring humor to my lessons here. So a geologist. Here's my silly joke of the day. So what did the rock say to the geologist? Any guesses? Hey, don't take me for granted. Get it? Granite? Okay, alright. I've had enough for today. Alright, so moving on here, guys. How do we know what's going on underneath our feet? We have never been to the center of the Earth, despite any movie you may have seen featuring any Hollywood actor. We have never been down more than a couple miles drilling underneath our feet. So what we do, we have to use what's called indirect evidence. We can't actually see with our own eyes. So it's going to put together clues using some different techniques here. In one, geologists record seismic waves from earthquakes and study how they travel through the Earth. The speed and the paths the waves take help reveal how the planet is put together. And we'll talk a lot more about that later on. That's one of our big ways we use, or big types of evidence we have, is recording these seismic waves all over the Earth and studying how they travel through the Earth from an earthquake, and if some make it to the other side of the Earth, if some don't, if they maybe been reflected or refracted, they've been bent. That can also change how they travel. That's the idea of indirect evidence. We'll do a lot more with that later on. So let's get right to our layers of the Earth. And starting here on top of the Earth, we have, of course, the crust. And the crust is a layer of rock that forms the Earth's outer skin. And it's just about 5 to 40 kilometers thick. The range is from 5 to 40 kilometers thick. So it's actually very thin. You think it's a long distance. It's not. If you think about the crust of the Earth, think about it like the skin on an apple. That's all the thicker the crust of the Earth really is. It's actually a very, very thin layer of all that solid rock. Now, and there's two different types of crust. All crust is not created equal. The crust beneath the ocean is made of a rock called basalt, which is much denser. It's a darker rock. And so the oceanic crust is denser. It's going to sit a little lower. It's also typically thinner. And then the crust beneath the continents is made of granite. And so beneath our feet, that's mostly granite, which is a lighter, less dense rock. And that'll come into play later on in the chapter when we deal with subduction. So there's two types. And again, when we deal with the layers of the Earth, we'll jump to a picture here. And so we are looking at two parts here. We have the chemical composition, that's on the left-hand side, and more the physical composition here on the right-hand side. So our first layer, this crust, you can see very, very small. At the deepest, it goes down to 100 kilometers, they say. And so it's very top layer. That's all the solid rock that's on Earth there, made of that basalt and granite. And over here, we look at our physical composition. The actual solid rock on Earth, we call it the lithosphere. So that's all the crust, and the very top of the mantle, that's rock that's still solid. It's not melted or can move yet. It's still solid rock. But that lithosphere, again, is what's solid. So chemically, it changes. Once you get into the mantle, the rock is going to change chemically. It's not going to be this basalt and granite. It's going to be different types of ores, I guess we'd say, or elements in there that form the middle layer, which is the mantle. Okay? And so we're going to do more. We're going to come back to this picture. Right now we're dealing with that crust, that very top layer. So let's jump back. We did our crust. Let's move on to our next layer, which is the mantle. So going down to the mantle is beneath the crust, and it's a layer of solid hot rock. So, and it's kind of a weird layer. It's going to be broken in two different parts here. The mantle, the uppermost part, of the mantle is that lithosphere, which is also part of the crust. That's solid. It's still solid rock. So the lithosphere is that rigid or solid layer, so it's still solid rock. That's a big deal. So now below that, we have what's called the asthenosphere. The asthenosphere is a softer layer that can slowly flow. So these molecules, now the rock is getting hotter. Remember, the deeper you go, the hotter it's going to be. So at this depth, the rock is hot enough that it can kind of start to, there's also more pressure the deeper you go. So it's kind of that layer where it's right at the right temperature. It's not too hot yet. There's not enough pressure. So the rock can kind of almost bend. Think of it like a silly putty. It can kind of be a solid. You can put things on it and kind of support it, but you can bend it, you can ply it. So it's kind of like a silly putty or Play-Doh, where it has, it's a solid most of the time. You can put it into shapes, but it can bend and slowly flow. That's going to be a big deal. This is a very important force that affects a lot of things on Earth here. So this idea that the asthenosphere can bend is a very big deal. And what happens here, and we'll talk more about this later on in the other units and lessons, is in this layer, since that layer can kind of slowly move or bend, what are called convection currents take place in the asthenosphere. And basically this is a big circular current that kind of rock is constantly moving and cycling through the asthenosphere. We'll do more with that later on. It's a very important idea though. So the asthenosphere can move, and this is where convection currents take place. All right, so next, we've gone down through the mantle. Most of the biggest part of the layer of the Earth is the mantle. And below the asthenosphere, they call it the mesosphere, the rest of the mantle. And now we get down to the core. Again, the core is that next layer, so it's chemically different and also physically different. The core of the Earth is made of iron and nickel. It consists of two parts, the outer core, which is molten metal. So molten means liquid. It's hot enough down there that it's melted iron and nickel just kind of flowing around deep within the Earth under a lot of pressure from all that weight of the rock above it. So now, at a certain point though, the pressure becomes so great as you get deeper and deeper into that inner core that now, even though it's hot enough to melt, it should melt this iron and nickel. There's so much pressure that the molecules can't spread out enough to become a liquid, so it stays like a solid ball of iron and nickel, even though it's very hot. And we've talked about magnetic fields earlier in the year. This dense ball of iron floating in that core is often, that's why we think we have our magnetosphere that protects us from the sun. So, and let's take a look at this here on our chart. So here we have our chemical composition. We have the crust, that very top layer there. We have the mantle. And again, you see in there is the asthenosphere. And in the asthenosphere, this is where we have the convection currents taking place, so that top part of the mantle. So we go down to the mantle. Now it's solid. There's enough pressure that it's going to keep the rock solid. And at a certain depth here, we start to notice that it becomes liquid. And that goes back to, how do we know that? We know that because those seismic waves we'll study more later on. So now we're into the core. And we're pretty sure the core is made of that liquid iron and nickel. And so when we get deep enough, we get to the inner core, which is now solid. And so again, the big thing here, the physical differences are listed on this side: lithosphere, that asthenosphere in the mantle, down to the outer core and inner core, those physical differences. So 8th grade, we are going to stop here. I thank you for watching this video, and we'll see you guys along the way.